Welcome, everyone, to Power Bytes. I am your host, Lou Signorelli, and Power Bytes is your destination podcast for power generation conversation. As always, please know how much we appreciate you, our listeners. We hope you find our topics both helpful and interesting. There are several ways for you to get in touch with the show. You can send us an email at powerbytes, that's power, B-Y-T-E-S, at cat.com. Visit us on Cat Electric Power on Facebook or LinkedIn. If you enjoy our time with us, please remember to subscribe to our podcast wherever you happen to listen to your favorite shows. One topic that continues to confuse genset users around the world are ratings. A, they seem to mean different things from different manufacturers, and B, who has time to keep up with them all? Well, today we're going to attempt to shed some light on a few of the ratings we see a lot at Caterpillar. Joining me today via the Cat Electric Power hotline is Brian Snyder. Many of you will recognize Brian from his work on other podcasts with us. Brian has 18 years of experience at Caterpillar with a career focusing on integrated systems and gensets. Brian, we're delighted to have you back.
Thank you for having me, Lou. I look forward to covering this topic with you today.
Can you start us out with a brief definition for generator ratings and why we even have them?
Certainly. So generator ratings are made up of two primary components. There's a numeric value, which describes the amount of power that we can get out of a specific product. And then there's the named rating category, which describes the operating conditions. These are things like the load factor or the hours of operation that we can get out of a product in a given year. So together they define the operation of the genset and how that impacts the overall life of the generator and even the maintenance intervals that we expect to see from a generator.
So the ratings become an important part of how a user determines which one to buy. Are there any standards organizations, though, that help govern the genset rating categories?
Yes, the International Standards Organization, or ISO, is most commonly referenced for their reciprocating engines, and their standard, the ISO 8528, is one of the most common standards we have. It has Part 1, which defines the application, rating, and the performance of a generator, and in their 2018 version, you'll find the power ratings section within Section 14 of that Part 1.
So can you provide us with a brief overview of the rating categories that are defined by ISO?
Yeah, let's start out with the continuous power, or COP as it's referenced in the standard. The continuous power applications are typically those which have a consistent electrical load, and they have 100% load factor allowed for unlimited hours. So normally you're going to think about these in applications that may be like a mine, where the load is fairly consistent, it runs 24 hours a day, and so you're always getting the same amount of power. The generator is able to remain fairly consistent. The next rating category is the prime power, or the PRP in the standard. These are a little bit different in that they allow for a variable load. Typically, they consider a 70% load factor, which means that over the course of a day, you may have some variations. During the day when everybody's up and working, you've got quite a bit of power usage, but maybe at night, the power rolls back. And so over the course of a day, or even over the seasonal, you'll end up with around a 70% load factor operating on the unit. The prime power applications also allow for unlimited hours of operation. But they also have one stipulation that allows for a 10% overload condition. So maybe you have an opportunity where you have a spike in loads for a very short period of time. Typically, it's only going to allow for 1 hour in every 12 to have that 10% overload. So an application you may see for these prime applications is something like an island, where during the day, you've got a lot of people that are using the power, so it's going to go up a little bit, but at night, it's going to go back down, and you just don't have a utility available, so the prime generator set would be the one that would operate to help support the island. Now, there's one thing to note right here at this point, I guess, is that there's a lot of complex stipulations associated with each one of these standards, so it's important to make sure if you're looking for the detail to look at the ISO standard, we're just giving sort of a generalization here. If we continue on down the list, the limited time running power, or LTP, is the next. LTP allows for 100% load factor, much like that continuous power application. However, it reduces the amount of hours that you could use to only 500 hours per year. So these are going to be applications that have a semi-reliable grid where you assume that you're going to be connected most of the time, but there's times where you're going to need to be able to run and the generator is going to be the consistent power for the application. Another one then is the most common rating category is emergency standby or ESP. Emergency standby allows for a variable load, and much like the prime power, it has a 70% load factor. So we've got some variation over the course of the operation. The big difference with the emergency standby is within the ISO standard, it only allows for 200 hours per year of operation. So these are applications where you have a reliable grid, but you need to have just something that's there to provide backup in case of an emergency. And the last rating category we'll cover is one that is the newest to the group of ratings, is the data center power, DCP. There are several things within the DCP that are a bit different than all the other ratings, and that one of them is that it allows for either a consistent or a variable load. It allows for 100% load factor and unlimited hours, much like what you would see from a continuous generator set. The biggest stipulation that's different is that it has a statement that states that it is dependent on the site to supply and the availability of a reliable utility. So this is the only rating that actually does reference a utility within it, but these are intended for data center applications, which are very prominent in the industry today.
Thank you for that very nice walkthrough, Brian. I appreciate that. So as you said, there's more details to these definitions that our listeners could reference in the standard, and we probably encourage them to do that, as you mentioned. But do you see any significant deviations from the standard definitions in the industry usage?
Absolutely. So the standard itself is really a baseline and is intended to be an agreement between the customers and the manufacturers, as really a baseline of how the products are going to be built and designed. But in the end, many of the manufacturers have some slight deviations to allow for some capability and to try and help market their products. For example, Caterpillar has a standby rating where we allow for 500 hours per year instead of what we would see from the ISO standard, which has a limitation of 200 hours per year. Over time, we've seen other things that have come out. There were other manufacturers that came forward with increased load factor on their standby rating to allow up to 85% load factor. Caterpillar, several years ago, responded to that with the ability to provide what we called the mission critical rating. It has an 85% load factor and 500 hours per year. It's one of the most common that we're using today for a lot of things like data centers. So overall, it is important to work with the manufacturer to understand the stipulations that they have and the guidelines that they have for their specific ratings and what are the real limitations for how their product should be used.
Brian, this all seems a bit confusing to me. So let's boil down this to practical terms on how this impacts our listeners. Can you walk us through how the time elements of the different definitions impact power output?
Yes, if we were to take a specific engine configuration, so a group of iron and an iron set that we may have for a generator set, and the physical properties of that material is really limited by the temperature and time. So if we were to think that if we run an engine cooler, that engine's going to last longer. And if we run the engine hotter, then we're going to need to be doing more maintenance. It's much like what you would consider for your own car or something of your own use. If we were to use a real example, we think about, say, a standby generator set that's rated for 2,500 kVA. We would operate that at an average load factor for the 70% load factor we discussed would be 1,750 kVA for less than 500 hours per year. Just to be clear, it can produce the 2,500 kVA if it's ever required to do so. The generator is capable of it. However, as we talked about, there should be variable load. So that's where we would see that the average load factor is that 1,750 kVA. Over time, if we were to assume that that's our standby generator set and that's the rating, if we were to take that same generator set and we would look at that in a prime application, so the same physical material rated for a prime application, we're now talking about a generator that can operate with unlimited hours. So our 70% load factor we would reduce the overall rating for the generator to 2,250 kVA, and that would put our 70% load factor at 1,575 kVA. So again, we can now then take that same generator set and rate it for a continuous application, where it's able to run at 100% load factor for unlimited hours. So in order to reach those operational characteristics, we need to again reduce the rating of the generator. So that generator would be rated for 2000 kVA. So you can see if we take the same product and we're running it for a short period of time, we're able to run it at a higher power. So we're at 2500 kVA standby. But if we're going to run it at its maximum capability, that would be a lower power set, which would be around 2000 kVA.
Thanks, Brian, for taking us through that. So it really seems like you must start with the user expectations of load and runtime and then move to the ratings to assure the expectations are met. Is that correct?
Absolutely. So the ratings are intended to help our users understand how much power they can get out of the generator set and for how long. It's really an agreement between the manufacturer and the user as to what the maintenance intervals and how to maintain and get the most life out of their product. We do sometimes see customers that misapply these ratings by maybe they'll choose a continuous rating because they don't want the limitations of, say, a load factor or operating hours. They just want to know that their generator is always going to be there to run. And what ends up happening is we end up oversizing the generator. So to get that same 2,500 kVA they would use for a standby, we end up having to use a much larger engine. And then when they operate it in a standby type application where it's not running as much and the load factors are low, you start actually having more problems associated with maintenance because it's not getting enough runtime and enough heat built up in the engine. It's important to understand that the limitations that we're talking about in these hour limitations are really a guideline for how the maintenance of the system should operate. Even with Caterpillar, with our standby and mission critical ratings, we have it defined that it's capable of providing power for the duration of the outage. So for an example, if you had a generator that had run for 490 hours over a course of a year, and now you've got a large outage that has just occurred, the generator is not going to automatically shut down at 500 hours. It's going to continue to operate and will continue to support you through that duration of that outage. Now, we would recommend that you would then work with your dealer to make sure that you schedule a maintenance at the next most convenient time so that you're checking out to make sure that it's still operating and will be ready for you in your next outage. But overall, the CAT product is going to continue to support our customers as it goes through those outages.
Brian, that's great information. And I think it's a bit more clear now on how this impacts the actual user. There is one rating that I would like to go back to that's really getting a lot of press lately. It's the new data center power rating you referenced. What can you tell us about this new rating and maybe the background behind it?
Yeah, the DCP rating came about based on a culmination of several different factors. Data center markets have been booming lately and really driving a lot of the requirements that manufacturers are building into their generator sets. So things like data centers are really critical to our way of life anymore and have become something that they need their generators to be operating and capable of operating whenever they need them. They don't want to put limits on the generator sets like we've talked about for hours in operation. What they've done is they've really tried to remove those limitations from the requirements as they specify their data center applications. We also have things like the Uptime Institute, which is a standards organization that certifies the design and the operation of data centers. And within the Uptime Institute's certification process, they've also looked at some of their more advanced designs are removing any limitations for the operation or the number of hours that you can get out of a generator set. So as we've seen that, there were manufacturers that have also now come up and tried to develop ratings around this application. And they've really tried to say that their product was specifically designed for these data center applications to meet these specific requirements. So as this market trend has been coming about, the ISO standard looked at that trend and looked at a way to try and help standardize that for the industry. As they put together the DCP rating, they tried to focus on these things of removing the load factor and removing the hour limitations that they had. Now, as they've gone about that, there are some factors that the market itself has not really accepted, things like the referencing to a utility needing to be available. So data centers and some of the other industries that are certifying data centers look at that as a stipulation that may be restricting the operation of the generator set in some way. So at this point, Caterpillar's still investigating this DCP rating. We're looking at how that applies and where in the world we might see that applying. Today, what we look at and use for most of our data center applications is we use a mission critical rating. It's what we've seen is most effective and most cost effective for our customers. So in the end, what we do is if there are stipulations where we need to certify something or provide additional requirements above what we state in our standard mission critical, we can do that. And if our customers reach out to their CAT dealers, we can put together letters and certify those products and be able to certify that the product meets the requirements that they need for their specific application.
So, Brian, I've been frantically taking notes during our conversation, as I often do, and it seems that the takeaways really come down to this. First, ratings are a baseline for understanding a genset's capabilities based on a specific life expectancy. And then, for the most part, it's an evaluation of temperature over time. So if you need more hours, for example, you're going to get lower mean power, which in turn delivers a lower temperature. Fewer hours required, basically, the more power you can pull from the generator, knowing it's not going to run for a long period of time. With a noticeable factor being that CAT gensets are capable of providing power for the duration of the outage. Did I get that right?
Yes, you got it exactly right. And so we have much more in-depth presentations and white papers on this subject. If the listeners would like further discussion on the material, I'd ask that they reach out to their CAT dealer and request further support. We'd be happy to work with them to make sure that they're getting the specific rating that they need for their specific application.
Well, there you have it, folks. I'd like to thank you, Brian, for sharing your insights with us on this topic. And thank you, our listeners, for listening to Power Bytes. For more information on ratings, please contact your local dealer for Caterpillar's comprehensive ratings guide. I find it fascinating to leaf through and look at all the different ratings and gensets, etc. If you'd like to suggest other topics for the program or have some feedback to share, please write us here at Power Bytes. That's Power BYTES at cat.com, or visit Cat Electric Power on Facebook or LinkedIn. Please remember to subscribe wherever you listen to your favorite podcasts. And until next time, thanks for listening to Power Bytes and have a great day.